you want to make sure that you don't go walking in front of it. Did I say something about that the other day? Yeah, well, you don't. You don't want to walk in front of it. And the reason you don't want to walk in front of it is because it's available to anybody unfiltered in the world who has an internet connection.
Oh.
Yeah, so right now, you could be in Zimbabwe with an internet connection, or sitting on a jet with an internet connection. Watch what's going on. So this here, so this is Buzz. This is the ATSVS. Have you been on it with Mr. Fontenot yet?
And
Yeah.
world history and Spanish.
Oh, Spanish. Yeah, that's right. Spanish 1 and 2 may be using this, right?
Yes.
Okay. Under what circumstances would you use it for geometry?
I would rather use it.
Nice that you're writing the rules. You would never use it. No, there's only one circumstance that you might be using it. What would it be? Do you remember? If I'm sick
Oh,
and I'm
right.
too sick to teach, then you're on it. Okay? So if I'm too sick to teach, I'll shoot something out of Google Classroom, and it will probably come to you in email, and just, there'll be all kinds of information saying what and how to get started with it. And more than likely, it'll be in this document here, the one that we have on the running day by day. And if you're on this using Buzz or whatever, what do you guys call it in the classes here? You call it Buzz or ATSBS or?
Buzz.
Buzz, okay. Because you use Buzz for BYU classes as well. Buzz is just the platform. But anyway, if you're on it, I'll have instructions on here again about where to go and what to do with it and all. But essentially, right now, what I want to make sure is that you have geometry on your list. Do you remember seeing it?
Yes.
You do, okay. And then when you're in geometry, have you been shown how to move around on this thing now?
A little bit.
A little bit. And if you're using it, you'll be better at it than I know. So right now, if you went into geometry, you would only see this right here. And you're probably only going to see module 1 and nothing more if you ever have to use it, because I'll get rid of the rest of the stuff. Excuse me. So with this here, this module, this could be 3 or 4 weeks worth of work, because I think there's either 9 or 10 modules, and if you divide that up by 36 weeks, then you're going to have like 3.5, 4 weeks or so of work in every single module. And I guess the one thing to remember with this is that whenever it's clear, a clear icon, that's going to be some kind of instruction or information. And whenever it's got the little blue markings in it, that's some kind of a quiz or an evaluation. So these things are all set up with, like here's a lesson on the basics of geometry. And this actually has some of the stuff that we're doing right now with point and line and stuff like that. And there are 9 pages, so when you're within a lesson, this is your navigation tool right here. You got that much already from where you've been using it? And then this up here, this is navigation through each of these. This bumps you from one to the next. So this has 9 pages. And this is how you get through all the pages. And it's kind of weird about the things. You'd think, like here, I'll drop down and go straight to the 9th page. You would think that when you're on the 9th page and you click forward, it would take you to the quiz. It doesn't. It takes you to the next lesson. So it skips over the quiz. The only way to get to the next quiz right from here would be either to use these arrows for navigation, or if you scroll way down where it says next activity. That would be the way to get there, or you can go the long way, you can go back to here, click on that, and then that takes you to the quiz. You get one shot at it. Some of these are matching, choosing what goes with what, naming, multiple choice. But there's like 5 or 6 questions, 7 questions for each of these lessons, which is kind of a checkpoint. If you submit your answers, whether you answer them or not, it goes in one time. I got everything wrong. But what it will do is, in many cases, it'll tell you what the correct answers are. So the idea is to give you quick feedback. And you'll be able to move on and do the next word. But We're not gonna work on it, we're not gonna practice using it. Middle school is going through it for 2 weeks. I'm not with me, but some of the other teachers. I'm just gonna look at it and figure that
Who's
you,
their teachers?
huh?
Who's their math teacher?
Well, other classes, like for language and such, they're doing this.
Oh.
You know, they still have me for math, but, I don't feel like dwelling on this with you guys, because I figure you'll be able to just pick right up on it when and if the time comes, if and when the time comes. Is that all right?
Yep.
All right, so, then, don't need this. This is kind of your lifeblood, in this document right here. That's what you want to live by, and I'll try to keep this one on the top of this list so you can find it real quick and easy if you wish to. And that's gonna have the live feed link and the playlist link. I took those off of the regular Google Classroom because I just couldn't get them right. I don't know why, it just wouldn't do it. So at least I couldn't make it do it. So these links work, these are good. Did I show you these the other day?
Yes.
Yeah, this is gonna go to the, like if we clicked on this right now, that's me at the beginning. So, everything comes in a loop in like a couple of seconds. Yeah, this going up in the middle school, it was really clear and it just kept going around and around, the same thing being said over and over. That'll drive you crazy. So, the playlists, this is Friday, I guess? Is that right? Friday was the 21st? This is you guys, last Friday. 14 minutes and 57 seconds of just blah, blah, blah. And the one that we're doing right now will populate into here as soon as I move it there at the end of the day. So, you know, if you needed to get back at something, heaven forbid, or if you're bound to home, and you like Sally is because she's quarantining right now, but she might be watching right now, or if she decided, hey, it's sunny, I'm gonna be outside, she might come and look at this another time, and then she would go to the playlists and look it up, and that would work the same way for you guys. If we go to, everyone stays home, because there's a case in school and they gotta do tracing and all that business, and it's gonna take time. But if something happened and we're out of here, we go home, check Google Classroom, I'll tell you when I'm gonna be live streaming, and you can either watch the live stream, or you can see it once it's in a playlist. But we're still gonna have class as usual. We're not gonna use Zoom at this time. We were gonna use the YouTube Live. That seems to be something that's gonna work out. So, any questions about any of that? No. Okay. Then, actually, I do want to go to this and make sure that we say what we need to say. Points and lines. This is where I'm at right now with you guys. So the terms coordinates, do you know what they mean when they say coordinates? This is going to be like in your way, isn't it? I wonder what we can do. If it was back here, it's not in your way, is it? But the $1,000 question is, you can zoom in. We're going to find out whether you can see it or not. I don't know. Trial and error. So I propose. Might not be able to hear me though. Yeah, we'll see.
You could hire a grip.
I could.
Yeah.
I could pay you to be the grip.
You just hold it up with your hand.
Yeah. Is that what the key grip is, the one that's like in charge of holding on to all the cameras and all that kind of stuff? You know, when I walk in front of it, that's good. I always wondered what key grip was. You know, you're watching the movie credits and they always say the key grip. It's like, yeah, you want to do the key grip? Maybe. So, coordinate. You know what we mean by a coordinate? that have coordinates on it?
Yeah.
Yeah. And this is a number line that is now coordinatized, because these are, 5 and -4 and 0 and 1 and 2 and 3, those are all the coordinates that are marked. And because we put them onto a number line, it becomes coordinatized. So this is a coordinatized number line. If I did this, had an X and a Y, then that would be a coordinatized grid. So it's just formality of things that you already know. So I said the other day that we don't really have a definition for points. We just have this idea of what a point is. So if you think of a point as a location, a very, very specific location, and that location is not going to be big. It's going to be like an exact point. And that's weird because I don't want to use the word to define the word. So we don't want to do that. It becomes circular. We'll talk more about that in a few days. But if we just have an exact location, and we can all agree upon the fact that an exact location is like a really, really tiny place that isn't going to have size to it, that's what we're going to call a point. And then a line. What did you guys say a line was? What kind of ideas did you say the other day that a line was? Is this a line? Is this a line? You could think of that as a line, right? But it's not really a line the way we think of line. We think, oh, that's a curved line, or that's a curve. But a line, did somebody say something about a dashed line on Friday? Was that this class or another? It's kind of weird because it happens twice. When you go over things twice. But you could have a dashed line like that. Is that really a line though? No, but we describe it as being dashed. Could I do this and have it still be a dashed line? Now the dashes are closer, right? So if we think of a line as a bunch of points like this, and then if you could put points in between the points, and every single time you did that, every single time you added points between the points, they created this idea that there was the shortest distance in between the points. Or in other words, if I had 2 points on a line, all of the points in between here would still maintain this idea of the shortest distance. So if I added another point in here, we would still have the shortest distance between 2 points. But if I took and put that point out here, now what I did is I didn't create the shortest distance between these 2 points. I created a longer distance, so now that point's not on the same line. So with that kind of description, this is a line and that's not going to be a line. Lines are going to be what we call straight lines. Yes?
Why does it have to be considered the shortest distance?
I'm sorry.
Why does it have to be considered the shortest distance?
Because we kind of have to agree upon something. Otherwise, when you draw a line, it might look like that. And I might draw a line that looks like this, and we're saying we're both drawing lines, but these are very different. So if we include this shortest distance between the points, it's going to straighten out our line. And then every time we draw a line, it's going to be straight. And then all we have to do is worry about which direction it goes. Kind of picky, isn't it? I think that is the one thing that becomes frustrating for students with this class, is that stuff gets really picky and really exact. So if you can accept that that's going to happen, it makes it easier. So what do I have here? It's described as a set of points with the shortest path between any 2 points on the line. So you've got 4 points in a row like that. Now these two points have the shortest distance between them falling upon that line. So a set of points. But these aren't really definitions, these are just like accepted descriptions. Think of it that way. And then the only other thing I need to show you is distance. You guys remember the distance formula? Like from the beginning of algebra. Here. Let's do this. So if we mark these 2 points, call them A and B. How far are they apart? 9 units. How do you figure that out?
We did, with the absolute value or something like that. I don't know, we should write.
You could count them, right?
Yeah.
Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. Does it matter whether I go from left to right or right to left when I count? No, it's the same, isn't it? So, you said something about absolute value. Yeah, so the reason that we use the absolute value is because we can either say that it's from 5 to -4, or we could say it's from -4 to 5. So distance has no directional. So how far is it up to the border? About 40 miles. So if you're standing at the border, how far would it be back to here?
Oh, wait.
Okay. So we're here in Haines, right? There's the border. That's mile 0, that's mile 40, right? So if I drive to the border, I have to drive 40 miles. If I drive back to Haines, I have to drive
40 miles.
40 miles. It's always positive 40, right? Because distances are never negative. We don't do that. That would just be confusing as all that. So if we looked at 40 and 0, well, we could do this. We could say, well, that, I got 40 and I subtract 0, there's 40 miles, right? So it's like the difference between these 2 places. That difference becomes that distance. But if I did 0 subtract 40, that would give -40, and that's not a way to write a distance. So if you take the absolute value of that, that's 40. So we have to take the absolute value of this. And if I took the absolute value the first way I wrote it, what's the absolute value of 40? It's still 40. So it's going to work whether you read left to right or right to left. So here, let's just do it this way. -40 subtract 5 is -9, which has an absolute value of 9. Or 5 subtract -4 is positive 9, because we're adding a negative, or subtracting a negative, which is addition, and that's going to be 9. So now I just say, well, this is going to be the variable a, and this is going to be the variable lowercase b. We can just say this is going to be the distance. From A to B. It's the absolute value of the difference of the 2 values. Then there's one other way of writing it. Is this the way we showed it in algebra? Was it with the absolute value bars when we did the distance formula? Do you remember? I get it mixed up. The 2 books, Algebra and Geometry, show it differently. I don't remember if algebra does it with absolute value bars or with the square root. There's another way of looking at the distance formula. Is this. If we took A subtract B, and we found out what that value was, so that value could either be positive or negative, like right here, you either get a -9 or a +9. And then if you squared that number, if that's a negative number, a negative times a negative makes it positive. And if it's positive, a positive times a positive makes the number positive. So when you square it, the answer comes out positive either way. And then you take the square root of that. That's also equal to distance.
Isn't that just B equal A subtract B equals distance though?
Say that again?
Wouldn't distance just equal A subtract B though?
Because the square
Because of the square and the square root you need? No?
No, I'm sorry,
How's this
Lynn.
work?
Because if you take a minus b and you square it, you have a squared minus 2ab plus b squared.
Whoa, okay.
And remember factoring at the end of the year?
Yeah.
Let's say we did this, x minus y squared is equal to x minus y times x minus y. You do x times x,
Oh,
x
right.
times y times x, and y times y.
So
and
It's a
you
whole
apply it.
weird little, yeah.
Yeah,
So
so
if the
that's the
2 was
square
on the
root.
inside of the parentheses.
What's that?
So if the 2 was on the inside of the square,
Then, yeah, if it was on the inside, then yes. But here, you would get something like this. No. That's evil right now, we don't need to go there. But, let's say we put our numbers in here. Let's use our -4 and our 5. If you have a -4 minus 5, then -4 minus 5 equals -9. That's in parentheses. Now, -9 multiplied by -9 is 81. Yeah, that's all right. And the square root of 81 is going to be 9. So the whole idea with this is it's going to come out positive every time because we only take positive out of our square roots. We don't consider the negative square root when we do this. You know, flip them around just for the sake of being able to do it. 5 subtract -4. That's squared. So this becomes 9. So now we have a positive 9, which is in the parentheses, squared. 9 times 9. You get right back in the same place. So you can use either this, or you can use this. I don't care which one you go back and forth between. But, you know, kind of be aware that that formula is the same as this. Those are both acceptable. It's like on ACT and SAT, you don't know which one they're going to throw at you. And they mean the same thing. So that's it. That's all I have. So if you go to Google Classroom, if you needed to look up the assignment, go to AAA, geometry, daily lessons, etc., you can take a look at it there. And I'll put it on the smart card too. So there it is, page 10, 14, 12, 14, 17, 18, 20. Yeah, go right ahead.